We have a new question from GATE 2019 from Chemical Engineering Thermodynamics. The question is, consider a vessel containing steam at 180 degrees centigrade. We are talking about the steam. The initial steam quality is zero point 0.5. Quality of steam is 0.5. Remember this term, quality of steam. And the initial volume of the vessel is 1 meter cube. Initial volume of the vessel is 1 meter cube. It is given at initial condition. The vessel loses heat at constant rate Q under isobaric conditions, so that quality of steam reduces to 0.1 after 10 hours. This is the isobaric condition, right? Means constant pressure process. The thermodynamics properties of water at 180 degrees centigrade are given as specific volume, specific internal energy, specific enthalpy, right? G is the vapor phase and F denotes is the liquid phase, right? The rate of heat loss Q is given as. So we will start with a solution. We will start with first law of thermodynamics. What is the first law of thermodynamics? First law of thermodynamics tells us delta U is equal to Q minus W, where delta U is the internal energy, Q is the heat interaction, and W is the work interaction, right? We can say it is we are giving Q heat to the system and W is the work done by the system. So I can say it is minus W. So okay, work done generally given as W is equal to P into delta V, you know very well, and we know that it is a constant pressure process, so W is equal to delta PV. We can write it as delta PV. P we can take it in the bracket. Then delta U is equal to Q minus W, we know that, so delta U is equal to Q minus delta PV, right? Then delta U plus delta PV is equal to Q, right? So we can take delta outside the bracket, so U plus PV, and we know very well U plus PV is nothing, it is a enthalpy, it is H, so we can write Q is equal to delta H, right? You can understand it, where delta is the change in enthalpy. Now heat release can be calculated as Q is equal to M H2 minus H1, means small h. Small h here denotes the specific enthalpy. Specific means enthalpy per unit mass, heat per unit mass, energy per unit mass. Whenever I talk about specific, that means it is per unit mass, and M is the mass, right? Mass of the steam. Now next, specific enthalpy. Small specific enthalpy is the H2 is the specific enthalpy at final steam quality. And what is the steam quality here? Steam quality can be defined as the amount of vapor divided by total amount of vapor plus liquid. For an example, if you have 1 kg steam, and you know very well that zero point 0.4, let us assume that 0.4 kg is the vapor and 0.6 kg is the liquid, so quality will be 0.4 kg divided by 0.4 kg plus 0.6 kg, so zero point 0.4 is the answer. 0.4 will be the quality of steam. Quality means how much amount is in the vapor phase, right? So, and we know final quality of steam that is given in the question is x2 is equal to 0.1. Next, given data, we have given these values, these thermodynamics properties, Hg and Hf. This is the vapor phase enthalpy and Hf is the liquid phase enthalpy. But we want to calculate the enthalpy of the final enthalpy, means at quality of 0.1. Since our final quality is 0.1, so we need to calculate H2. Actually it is H2, right? Here it should be H2, I forget it. H2 is equal to x2 Hg plus 1 minus x2 into Hf, right? Then H2 will be this, we will put the values, zero point 0.1 into 2778.2 kilojoule and this, and we get the answer H2 is equal to 964.7 kilojoule per kg. This is the final specific enthalpy. See the unit, right? Now again, initial quality of steam we have given is x1 is equal to 0.5, right? Now we want to calculate the specific enthalpy at initial steam quality, right? So we will do the same thing. H1 is equal to x1. Why I am multiplying this x1 with hg? Since x1 is the amount of vapor, it is talking about the quality of the vapors, you can say quality of the steam, ठीक? So h1 is equal to x1 into hg, and 1 minus x will be for liquid, so I am multiplying it with hf, right? So again I will, hg and hf value will be same, and just quality here change, 0.5 into this and 1 minus 0.5 into this, and the right answer will be h1 is equal to 1770.705 kilojoule per kg, right? Next, we have given steam temperature 180 degree centigrade. We have given VGVF also. VGVF means specific volume of vapor. Here it is a specific of vapor, specific volume of liquid, and quality of steam initially we have given x1 is equal to 0.5. What you can do now, specific volume also can be calculated with the help of this formula, V is equal to x into Vg plus 1 minus x into Vf, right? Please remember this formula, it will applicable on HF. HV means specific enthalpy, specific volume, specific internal energy. You can also apply it on specific entropy with the same formula. You don't need to remember this, I have told you that, right? Just multiply x with the Vg and 1 minus x with the Vf term, right? Now I have put the all values. Since this condition is given, why I am taking the initial quality? Since I know the initial volume of the steam, right? Now I know the specific volume. Again, mass of steam can be calculated as V upon V, where V is the vessel volume, which is given as 1 meter cube, and V is the specific volume of the steam at initial condition, right? So mass of steam will be 1 meter cube upon 0.09758 meter cube per kg. So the answer will be m is equal to 10.247 kg. This is the mass of steam. Next, given quality of steam reduces from 0.5 to 0.1 in 10 hours. It is given in the question. Read the question carefully again, right? We have given quality of steam reduces from 0.5 to zero point 0.1 in 10 hours. See, now we have calculated three values. What was the formula? We know the formula was q is equal to m into h2 minus h1. Now I have calculated h1, h2 and m. Now I just need to put this value and find out the final answer. Q is equal to m, h2 minus h1. I have put the values. Now I got this answer, minus 8 to 59.133 kilojoule. Since this amount of heat will release in 10 hours, it is given in the question. Since the quality of steam is reducing in 10 hours from 0.5 to 0.1, so negative sign will show that amount of heat is released from the vessel. Now final answer will be heat released per hour is equal to 8259.133 kilojoule per 10 hour is equal to 825.91 kilojoule per hour. So this is our final answer. This is the very important question from the GATE point of view. It can always ask, and so many times these properties can be asked in GATE. So thank you so much. Please subscribe my channel so that I can continue to give you solution of all GATE papers.